Hi, and welcome to this AI and C# video on the Microsoft Agent Framework. We have another video on RAG, and that is some techniques of improving quality. So why is this needed? Well, if you've seen the previous video, the introduction of RAG, which I highly recommend you do before you see this one, we had a problem. We didn't really do anything about it other than talk about it was worse. But let's have a look in a little more details. So we asked the question, what are the three highest rated adventure movies? And when we didn't use RAG and just gave all 100 movies in our example, we got a fairly good result with the highest rankings here. But the problem with that, while it was a really good answer, it cost us a lot of tokens, like 7,000 tokens down here. Then we began to use RAG, and then quite simply just added our data into a RAG database and did similarity searches and asked exactly the same question. And while we got our tokens down, which is the primary reason for RAG, we actually got a pretty poor result. So we saw that this dark labyrinth was 8.3. So none of the original ones were here. And you could argue if I run this multiple times, I might not even get the same here because the question was adventure movies. And none of the data mentioned what an adventure movie is. A movie could be a drama, it could be a sci-fi, it could be an adventure movie, it could be a fantasy movie. So sometimes even the AI would give us back different results in sample one. But over here, we got a more poor result because we didn't load up among all the 100 movies. We only took in the last, the 10 that had the most similarity search with our question, which was about three highest rated adventure movies. And similarity search is kind of dumb in that if the word rated had been a lot in some plot, it might have actually said that that's the most correct movie to present here. So what do we do? Every situation is different, but let's imagine we had this specific result problem here, and see what I in real life would try to do about this, because my users came back and says this AI is bad. It can't even give me the right things back. And the problem, of course, is this is just one question. There could be a million different questions from the users, but we're gonna focus on this one, but also see what we can do about various things, because similarity search is the one that are the broad kind of questions, but the more we know the type of questions, the more advanced we can become in our system. So let's jump in and see some options. And first up, I will quickly go through what I have done in this advanced RAG techniques compared to the original one in the first video. So what I've done is I'm still using exactly the same data. I just have a copy of it here. And I'm still using embeddings. I've taken away the preload stuff and so on. And what I've done, I've switched to a SQL Server vector store. So you can see that as an example. But if you would, you could run this scenario in memory still by taking this in instead. But it will just take a long time because the embedding is fairly more advanced in this scenario. So we are now having a SQL Server collection, and that collection is now being checked because we have a collection existed async. And if it doesn't exist, we will import the data every time. Else we will ask if we want to re-import the data, because we want to run this again and again and not sit and import exactly the same data into the database. So we still have our question, and then we can do various different things. The first thing we could try to do is to rephrase the question. Because in the original one, we just went in and asked exactly the same question as the user did. What are the highest ranking movies? But that might not be the best for similarity searches. So in this case, we're doing some fairly simple things. We're doing the original embedding like before, but the only thing we're doing differently is we are deleting the collection and adding it again, because now we have persistent data. But else, this is exactly the same as the original example. We're also doing the original search tool. I've just pulled it out into a class by itself, but nothing have changed here. And of course, one of the things we could enhance was, let's get 50 of the movies instead here in the similarity search. But we're not gonna try and go there. We might want to, in the beginning, because it's an easy one, go to like 25 instead. And what we're gonna do then is give better instructions. So far, my instructions has been fairly simple, but in real life, instructions can be very, very elaborate. So, for example, here I'm still asking it to work with the made-up movies, but and I have now taken the thing that was in the question before and put it in here, so the user don't need to tell how it should be shown. But I'm also saying, when using tools, use keywords only based on the user's question, so it's better for similarity search. So in the past, the question was just passed directly onto the tool. Now we're instructing that, hey AI, you shouldn't do that. You should actually rephrase the question. In this case, I'm using a keyword approach. So I'm taking the question and making it simpler. But it could also be, in some cases, it's better to elaborate the question. Say, if the user just say something simple, turn it into a bigger question with more words, with more associated words, enriching the question. Sometimes that works best for RAG. Other times it's best to go down. In my case, I have opted to go down, because I find that would be the best scenario, because it's trying to find certain things like adventure and in the question. So by doing this and running this first one, let's see it. So it's starting up, and it's asking me to re-import the data. Let's do that right now. So putting in the data in our simple raw format and asking the question, but you can now see the question was highest rated adventure movies, despite our question was give me the top 3. So AI will still use top 3, but the search against our RAG data is a different question. And that makes this a better result. It's actually getting back quite a good result here with the same number of things. But that is still and quite expensive, and it's because we also used 25 movies now instead of 10. But just rephrasing the question to the LLM can give us better data. Let's see another way of doing things. And again, for each scenario, there's probably a better way of doing things. But in this case, we are gonna enhance the embeddings instead. So in this case, when we do the import, we're using an enhanced data embedding instead. And this embedding is that we actually use an AI agent to find what genre of the movie it actually is. And then we are going to save that into the database as well. So we are making an agent that says it's an expert in finding the genre of a movie. We are going to go to each movie, and for each movie, meaning the 100 times, it will actually ask for a genre here. And I will start the code because it takes a little while, and set a breakpoint here, and then I will explain what we're doing. So in our case, we're gonna re-import the data, but you will see that this takes longer now because every call we ask what is this movie's genre, and it came back with a genre of sci-fi. And then in the vector store, we have added one more field, genre here, and being able to use that in here. So in our database, which I can show now, if we go in here, we now see that we have a genre field here, and some of them are adventure, some of them are sci-fi, and so on. So the embedding part now becomes more expensive, but that might be a one-time thing. A movie won't change too much, but if you have very fleeting data that change all the time, this might not be a good idea because this is more expensive than the embeddings. But let's have it run its course here. So we can see it's working up its data. So I will just let it run here while we look a little at the other data. Because we are in the enhanced version here, and we have also made an enhanced search tool. Beyond that, it's exactly the same. I'm still gonna use the idea we got from version 1 about keywords and so on, but the enhanced search we will look at in 1 second once it's done with embedding, with the embeddings. So it's almost done here. And we have our embeddings complete, and we are ready to give it a tool that are more advanced. And the more advanced stuff is that our search previously just got a question. Now it also gets a question and a genre. And that might mean then if you ask a question that has nothing to do with genre, what should the AI do about that? We could make it optional like this. So there's all these things you can tweak. But what we're doing here is we're gonna make a filter on the search saying, and we're not gonna have 100, we're gonna have the 25 in here. So we only want the 25 back, but only the ones that actually have the genre it's being asking for. So if we let it run, we will now see that it asks for highest rated adventure movies with genre adventure. And now we get again back some of these higher results that we didn't see before. But one of the results that we wanted, which is this Wild Empire, and I don't think that's here, and despite it being the highest one. And the reason for that is if we look at Wild Empire, it's been classified as a sci-fi. So if a movie is close to being either adventure or sci-fi, AI might need to pick. So you might need to have multiple genres in the database. Again, there's no clear fit for every single scenario in this world. And the second you you put in an AI, the quality of your answer will go down. You can say what is it compared to. Say if it's compared to a human, that also classifies this as sci-fi, and then don't answer it back with adventure is another matter. But no matter what, there will be some inherent rules that an AI will use, a human will use, our code will use, that will degrade the answer. There's no single truth to what are the top 3 best adventure movies according to this. But if we do this, we at least go in and say all the other movies that was not adventure has been filtered out, and we only get the 25 that fits best similarity search with the genre of adventure. So the filter here is just link queries. It's sort of okay. It can't do contains and stuff, but it can do the basic stuff for filtering that you would, in this case, when it's a SQL server, be a where clause. So doing this, we saw that we got a better answer back. We still used a lot of tokens because we switched it up to 25, but we could perhaps go down here to 10 and still get closer and closer. So it's all a balance of what makes sense to do. The last thing I want to try and show is a little common sense as well. Because now we have learned AI, so now we sometimes think that we should use AI for everything. And sometimes a question like this is probably not the best to use AI. Probably the best would do to write this SQL statement, give me all the movies back that have the genre adventure, and order them by rating descending, and take the 3 top. Sort of what we get from the AI, but when we have more structure, we can write better code, faster code, more cost-effective code that way. So the last one here is actually using some common sense, but it's also using AI to figure out if it makes sense to have that common sense. Because it could be that the question have been, give me all the movies that mentioned the word water in the plot. And that would not be something we could just make a quick SQL statement. Yeah, we could say like water, but it could be another word that are associated with water. So sometimes our normal code breaks down. That's the main reason we have AI in the first place. But let's see the common scenario here. Let's set a breakpoint and run it, and then we can see. In this case, we don't need to re-import the data because it's using the same enhanced embedding here. So just gonna switch that. But now I have put an AI up front in that it's an intent agent. So it's instructed to infer what the user is asking for. And we just used normal structured output here with an intent response back saying what type of question is it? Is it a movie genre ranking? Is it a movie genre search? Or is it a generic movie question? And if it's a genre search, it can give a genre back and it can give a number of results back. So we get a response back, and in this case, the intent based on our question is that it can see it's a genre adventure. The number of results we want back, because we said top 3 is 3, and the question is a movie genre ranking. And if we do that, we have a case statement here for the types of questions. So we are quickly going to go into this a little while, but if it had been a generic movie question, we would just use the original search tool with the original data and our keyword search. Had it been our movie genre search, we would have used the enhanced search tool because we could then give a genre for it and write out the answer. While in this case, we are actually not going to use AI to grab the data. We're instead just going to use the collection, and it has a little get async, which has nothing to do with the vector similarity searches, but just give us all the ones that have the filter of the right genre here. So essentially we're going to go here, and the matching movies are these 26. And then we're just going to use normal C# code, order by descending grading, and take 3. And then we get the 3 movies that are highest of type adventure. And then we're going to let the agent say, you are an expert in the made up movies like normal. You are given the data of the user's question. So don't look at it, just present it. And we could also just have put them back, but then it would be a more robotic answer. Here we are using a small agent with only 3 results back to actually present that to the user. So if we do that, we end up with that the 3 highest rankings are these, and we use the least amount of tokens. So now you can see there's not just here some RAG data AI figured out. There can be various different ways of working with data. Some of them use more code, some of them use less code. There's no right answer to this because while this might be fairly simple to do, you need to write more code. And the second the user asks something you didn't anticipate, that could be something that didn't fall into the type of question you have, what to do then? And you could end up with some odd responses back and more robotic in nature. So giving AI the entire data and its free range of creativity, you get the most natural answer. But by doing things like these, all depending on your needs. So again, as I mentioned here, every situation is different. But now you at least know there's various different things when you try something and your users or yourself don't feel the quality is good enough, the style is not good enough. So increase the search results, rephrase the questions, enhance embeddings, filter, and sometimes we don't even need to do AI. Sometimes it is actually better just to do the hard work of normal code to do the right thing. So again, I can't give you the real answer here because it's different every single time. But at least I hope you are more informed now on what you can do more to make your RAG experience even better. So see you in the next one.